66 million years ago, it was an ordinary day on Earth. Vast forests stretched for thousands of miles, the oceans were full of life, and creatures weighing dozens of tons walked across the land. Dinosaurs had ruled this planet for nearly 160 million years. They had survived climate shifts, the movement of continents, and countless natural disasters. It seemed almost impossible that anything could wipe them out. But then, an event occurred that, in a single geological moment, erased them from the face of the Earth. 75% of all species disappeared, not over thousands of years, not over centuries, almost instantly. Today, scientists say the cause was an asteroid, a massive space rock that slammed into Earth and triggered a chain reaction of global catastrophes. The impact, global fires, dust thrown into the atmosphere. A sudden drop in temperature, ecosystems collapsing, and with them, the dinosaurs. At first glance, the explanation seems logical, but when researchers began examining the details of that day more closely, strange questions started to appear. If one impact destroyed everything, why did some species survive? Why do traces of destruction look different on different continents? And why does some evidence suggest that the planet had already begun to decline before the asteroid ever hit? To understand what really happened, we need to go back and reconstruct the last day of the dinosaurs almost minute by minute, because when you put all the facts together, it becomes clear that the story we are used to hearing may be far more complicated. And by the end of this investigation, we will uncover one detail that is almost never discussed, a detail that could change our understanding of how the age of the dinosaurs truly ended. 66 million years ago, an object about 10 kilometers wide was approaching Earth. It was an asteroid traveling at a speed of roughly 20 kilometers per second, about 70,000 kilometers per hour. For comparison, a rifle bullet travels about 30 times slower. When an object like this enters the atmosphere, the sky would flare brighter than the sun. A massive trail of fire would streak across the sky, and within seconds, the impact would occur. But the real catastrophe begins at that exact moment. The object slams into what is now modern-day Mexico, in the location known today as the Chicxulub crater. The crater's diameter is about 180 kilometers. The energy of the impact is estimated at roughly 100 trillion tons of TNT. That is billions of times more powerful than the nuclear bombs ever created by humans. In the first seconds after impact, temperatures in the collision zone rise to several thousand degrees. Rock, water, and soil instantly vaporize. An enormous fireball shoots high into the atmosphere. The shockwave begins spreading across the planet at supersonic speed. Everything alive within hundreds of kilometers is destroyed almost instantly. But this is only the beginning. Trillions of tons of dust, ash, and molten particles are blasted into the atmosphere. When these particles begin falling back to Earth, the atmosphere heats up like a giant oven. Some scientists believe that the surface temperature of the planet may have briefly risen high enough that forests around the world ignited almost simultaneously. Global wildfires begin. But then the next stage of the catastrophe arrives. Dust and aerosols block sunlight. The planet enters what scientists call an impact winter. Temperatures drop sharply. Photosynthesis nearly stops. Plants begin to die on a massive scale. Then herbivorous dinosaurs start starving, and after them, the predators. At first glance, the explanation seems logical. One asteroid, one chain reaction of catastrophes, one mass extinction. But when scientists began carefully analyzing geological layers across the planet, strange details started to appear. Some of them suggest that this story might not be as simple as it seems. And to understand why, we need to look at the first inconsistencies that researchers discovered. If everything really happened exactly like this one asteroid, striking Earth and triggering an instant catastrophe, then the geological evidence across the entire planet should look roughly the same. One layer of destruction, one moment in time, one global boundary between geological eras. And in fact, scientists did find such a layer. It is called the KPG boundary, a thin band of rock that runs across the entire planet and contains unusually high amounts of an element called iridium. On Earth, iridium is extremely rare, but it is abundant in asteroids. That is why in 1980, a group of scientists led by physicist Luis Alvarez proposed the famous asteroid impact theory. Their calculation seemed logical. If a layer of iridium exists all over the planet, then Earth must indeed have been struck by a massive object from space. At first, everything seemed to fit, but soon details began to appear that raised the first questions. In some locations, this layer turned out to be much thicker than expected. In others, it almost disappeared. If this was truly a single global moment in time, why are its traces distributed so unevenly? But that was not the only anomaly. In some regions, evidence of global wildfires appears earlier than the asteroid should have struck. In other places, ecosystems seem to have started collapsing tens of thousands of years before the supposed impact. The picture begins to look strange. If the asteroid was the only cause of the catastrophe, why do signs of extinction begin earlier? Some paleontologists noticed another detail. In the final layers of the Cretaceous period, dinosaur diversity was already declining. Some species were disappearing gradually, long before the supposed catastrophe. This may mean that the planet was already under severe ecological stress. But what could have caused such stress? The answer leads researchers to one of the largest geological events in Earth's history. An event that was happening at roughly the same time the asteroid may have struck the planet. Gigantic volcanic eruption. These eruptions occurred in what is now modern-day India and are known today as the Deccan Traps. When scientists began calculating the total volume of lava that erupted from these volcanoes, the numbers were so enormous that some researchers began asking a new question. What if the dinosaurs were not wiped out by the asteroid at all? What if the planet was already on the brink of catastrophe long before that impact? And perhaps the asteroid was only the final blow. But to understand the true scale of what was happening, we need to imagine just how massive those eruptions were. Because what was happening on Earth at that time looked less like ordinary volcanic activity and more like an apocalypse. Imagine a morning 66 million years ago. Somewhere in what is now North America, a massive Tyrannosaurus emerges from the forest, searching for prey. In another place, a herd of Triceratops slowly moves toward a river. For them, it is just another ordinary day. They have no idea that, at this very moment, an object in space is approaching Earth, one that can no longer be stopped. An asteroid the size of a mountain is racing toward the planet at about 20 kilometers per second. It has been traveling for millions of years, and the final minutes of its journey pass through Earth's atmosphere. As it enters the atmosphere, the sky would have flashed so brightly that it looked as if a second sun had appeared above the planet. Then the impact occurs. In the region of what is now the Yucatan Peninsula, the surface of the Earth is literally torn apart. A crater forms almost instantly. Rock, water, and soil vaporize. A massive column of molten material shoots tens of kilometers into the sky. But the real catastrophe begins minutes later. The shockwave starts spreading across the planet. The ground shakes with the force of an earthquake measuring around magnitude 11. For comparison, the most powerful earthquakes in modern history barely reach magnitude 9. Across the ocean, a giant wall of water begins to move. A tsunami, hundreds of meters high, races through the ancient seas. But there is one detail that is rarely discussed. After the impact, billions of superheated particles of rock are blasted high into the atmosphere. Some of them rise almost into space. Then they begin falling back down to Earth. And when they return, something strange happens. The atmosphere begins heating up as if a gigantic furnace has been switched on above the entire planet. Some models suggest the air temperature may have risen so dramatically that forests across different continents ignited almost simultaneously. Imagine that scene. A planet where enormous fires erupt almost at the same time. Firestorms sweep through forests. Smoke rises into the sky. Entire continents become covered in flames. But here, another mystery appears. Geologists have indeed found traces of these fires around the world. However, in some places they appear as if they did not occur all at once, but in waves. That suggests the catastrophe may not have unfolded in a single moment, but in stages. First, the impact, then the rain of fire, then global wildfires, then a sudden drop in temperature. But even this picture may be incomplete, because some studies suggest that even before the asteroid struck, Earth's atmosphere had already begun to change. Carbon dioxide levels were fluctuating. The climate was becoming unstable. Ecosystems were under increasing pressure. And here we return again to those volcanoes in India, to eruptions that were releasing millions of tons of gas and ash into the atmosphere, eruptions known today as the Deccan Traps. When scientists compared the timing of those eruptions with the moment of the asteroid impact, a hypothesis emerged that sounds almost like the plot of a disaster film. What if the asteroid did not simply wipe out the dinosaurs? What if its impact literally shook the planet and intensified the volcanic eruptions that were already happening, turning Earth into a chain reaction of global catastrophes? And if that is true, then the last day of the dinosaurs may not have been a single event, but the beginning of an entire series of apocalyptic processes that lasted for thousands of years. But there is one detail that makes this story even stranger. When scientists studied the Chicxulub crater more carefully, they discovered something unexpected. The asteroid did not hit ordinary rock. It struck an area filled with huge deposits of sulfur and carbonate rocks beneath the surface. This detail is extremely important. At the temperatures created by such an impact, these rocks would instantly vaporize. When that happens, massive amounts of sulfur are released into the atmosphere. Some studies suggest that more than 100 billion tons of sulfur gases entered the atmosphere. To understand the scale, that amount is enough to change the climate of the entire planet. When sulfur aerosols rise into the stratosphere, they begin to reflect sunlight back into space. The planet starts to become darker. Temperatures fall. Photosynthesis slows down almost completely. And without photosynthesis, the entire food chain begins to collapse. But here, another strange detail appears. Computer models show something surprising. If the asteroid had struck a different place on Earth, the consequences might have been much less severe. For example, if the impact had happened in the middle of the ocean, or on land without sulfur-rich rocks, the climate disaster might have been weaker. Some scientists even suggest that in such a case, dinosaurs might have survived. Think about that. The fate of the entire planetary ecosystem may have depended on one exact location on Earth, one point on the map. But that is not all. In geological layers formed after the catastrophe, scientists have found clear evidence of acid rain across the planet. This means the atmosphere became filled with sulfur compounds. Rain turned into a chemical solution that damaged plants and disrupted ecosystems. And this raises another question. If the catastrophe was so powerful and happened so quickly, why did some species survive? Small mammals survived. Birds survived. Crocodiles survived. Turtles survived as well. Why? Why did smaller and weaker creatures survive, while the giant dinosaurs disappeared? The answer may lie in how the extinction actually happened. Perhaps it did not happen in a single day. Perhaps it was a chain of disasters that lasted for years, or even decades. First, the asteroid impact. Then, global firestorms. Then a dark winter. Then, acid rain. And at the same time, massive volcanic eruptions. The planet may have been experiencing several global disasters at once, but even this explanation might still be incomplete, because some researchers are asking an even more uncomfortable question. What if the asteroid was not the real cause of the extinction, but only the trigger? What if the real reason for the disappearance of the dinosaurs began much earlier? To understand that, we must look at events that started hundreds of thousands of years before the impact. And this is where the most controversial and most intriguing part of the story begins. A few hours before the impact, nothing on Earth looked unusual. The sun was rising over the forests. Massive dinosaurs moved across the plains. Pterosaurs glided through the sky. For every creature on the planet, it was just another ordinary day. But high above the atmosphere, an event was already unfolding that would change the history of life forever. A massive asteroid was approaching Earth at a speed of about 70,000 kilometers per hour. It was moving faster than any bullet, faster than any aircraft humans would ever build. And most importantly, no creature on Earth could see it coming in advance. When the asteroid entered the atmosphere, it began heating up rapidly. The sky flashed with a blinding light. For the creatures on the surface, it must have looked as if a second sun had suddenly appeared in the sky. A gigantic streak of fire cut across the sky, but there was no time to understand what was happening. Within seconds, the asteroid struck the Earth. At the moment of impact, The planet's surface literally exploded. A crater nearly 180 kilometers wide formed almost instantly. Billions of tons of rock were blasted into the atmosphere. But the most terrifying part of the catastrophe did not begin at the moment of impact. It began minutes later, when the superheated particles of rock began falling back to Earth. Imagine rain, except instead of water, billions of burning stones are falling from the sky. The sky begins to glow red. The atmosphere heats up. Forests ignite. Firestorms begin across the planet. Some scientists believe that the air temperature may have briefly risen so high that animals died simply from the heat. But there is one detail that is rarely discussed. Calculations suggest that between the moment of impact and the beginning of this fiery rain, about 30 to 40 minutes may have passed. That means, in some parts of the Earth, creatures could have survived the initial shockwave without yet realizing that the real catastrophe was only beginning. Imagine that moment. The Earth has just experienced the most powerful earthquake in its history. The sky begins to darken. Giant tsunamis move across the oceans. And then, fire begins to fall from above. And this is where one of the most disturbing details of the entire story appears. The final hour of the Age of Dinosaurs may not have looked like a single explosion, but like a sequence of increasingly terrifying events. First, the flash in the sky, then the impact, then the earthquake, then the tsunamis, then the rain of fire, and then comes the darkness. And that darkness may be the most frightening part of the entire story, because after it begins a period that scientists call impact winter, a time when the sun nearly disappears from the sky, and it is this period that ultimately seals the fate of the dinosaurs. After the firestorms came what many scientists believe was the true cause of the extinction. Not the impact, not the earthquakes, not the tsunamis, but the darkness. When the asteroid struck the Earth, trillions of tons of dust, ash, and vaporized rock were blasted into the atmosphere. A massive cloud rose into the stratosphere and began spreading around the entire planet. Within days, sunlight started to disappear. At first, the sky became dim. Then the sun turned into a pale spot behind a thick veil of dust. And in some regions, near total darkness began to take over. Scientists call this phenomenon impact winter. Temperatures across the planet began to drop sharply. Some models show that within a few months, the average global temperature may have fallen by 15 to 20 degrees. For ecosystems, this was a catastrophe. Photosynthesis nearly stopped. Plants could no longer receive energy from the sun. Vast forests began to die, and with them, the entire food chain started to collapse. First, the plants disappeared. Then, the herbivorous dinosaurs. And after them, the predators. But there is one detail that makes this story even darker. This darkness may not have lasted for days or weeks. Some studies suggest that dense clouds of dust could have blocked sunlight for years. Imagine a world where, for several years, there is almost no sunlight, cold temperatures, collapsing ecosystems, constant fires, and acid rain. For giant animals that needed enormous amounts of food every single day, this meant almost certain death. But there is another side to this story. Despite the scale of the catastrophe, life on Earth did not disappear completely. Small mammals survived. Some birds survived. Crocodiles lived through the catastrophe. Turtles did as well. Why? Why did the giant dinosaurs vanish, while much smaller creatures managed to survive the apocalypse? The answer may not be only about size. Small animals could hide in burrows. They could survive on insects or decaying organic material. They could endure long periods without food. But giant dinosaurs could not. They required enormous amounts of food every single day. When the plants disappeared, their fate was almost sealed. But there is one more remarkable detail in this story. Even though dinosaurs disappeared, one group of them actually survived. And you may see them almost every day, because modern birds are direct descendants of dinosaurs, which means dinosaurs did not completely vanish. They simply changed. But this raises another question. If life managed to recover after such a catastrophe, could something like this happen again? Because Earth's history shows one troubling pattern. The planet has experienced mass extinctions before. and they have almost always happened suddenly, which means the last day of the dinosaurs may not just be an ancient story. It may be a warning. When we look at dinosaur fossils in museums today, it's easy to think their extinction is just a distant story, something that happened millions of years ago and has nothing to do with our world. But if we look closely at the events of that time, it becomes clear that Earth can change much faster than we tend to imagine. Just one asteroid about 10 kilometers wide, and a world that had existed for nearly 160 million years disappears. Entire ecosystems, giant animals, an entire era of the planet. And it all ends almost instantly. For the dinosaurs, it was an ordinary day. No warnings, no signals, just a morning that became their last. But the most interesting part happens after the catastrophe. Earth does not remain empty. In the place left by the vanished giants, small mammals begin to thrive, creatures that had previously lived in the shadow of the dinosaurs. Millions of years pass. These small animals evolve. They begin to walk on two legs. They create civilizations. They build cities, and they begin studying the history of their own planet. In fact, the entire story of humanity became possible only because, one day 66 million years ago, the dinosaurs disappeared. If that asteroid had missed Earth, giant reptiles might still rule the planet today, and humans might never have existed. But this leads to another thought. Earth is still in space, and asteroids are still orbiting the sun day. Scientists know of thousands of objects whose orbits cross Earth's path. Most of them are small, but some are large enough to change the history of life on this planet again. Today, for the first time in history, humanity is aware of this threat and is even trying to learn how to defend against it. But the story of the dinosaurs reminds us of one simple truth. The planet we live on is far more fragile than it seems. Sometimes, the fate of an entire era can be decided by a single rock traveling through space, which means the last day of the dinosaurs is not just the end of an ancient world. It is a reminder of how thin the line between stability and catastrophe can be.